At 10:10 hours on July 15, 2026, a massive Russian Mi-28 attack helicopter lifted off from a forward aviation base in the Belgorod border region. The mission parameters were standard yet critical. The heavy gunship was tasked to patrol the contested airspace, establish a low-altitude air defense network, and hunt the very unmanned aerial vehicles that had been systematically striking Russian ground positions. The morning flight profile appeared completely routine. The machine maintained a dangerously low altitude. It skimmed just above vast, open agricultural fields. It used uneven terrain variations and thick forest shelter belts to conceal its movement from observation posts across the border. The pilots flew with absolute confidence in their heavy titanium armor, their raw engine power, and their strict radar evasion tactics. But what the flight crew did not know was that the airspace ahead had already been turned into an invisible, inescapable trap. Since 800 hours that exact morning, 6 Ukrainian Shrike-10 FPV operators had been silently hiding inside the freezing tree lines. They were patiently waiting for the metallic beast to appear. Their high-speed civilian racing drones had all been heavily modified for a singular violent purpose. The small quadcopters carried heavy fragmentation warheads powerful enough to turn what seemed like a routine border patrol into a life-or-death battle in mid-air. Exactly 33 minutes after the helicopter took off, these ground operators would attempt an aerial ambush that no combat unit had ever successfully achieved in the history of modern warfare. The concept of using a cheap piece of commercial plastic equipped with a salvaged explosive charge to destroy a heavy gunship moving at 110 miles per hour seemed fundamentally impossible. But how exactly does a small infantry squad mathematically trap an apex aerial predator in the open sky? The solution to finding this ghost was not an active radar system, but an invisible acoustic web secretly spread across the entire border region. At exactly 800 hours, the mobile devices of all 6 Ukrainian operators vibrated in perfect unison. A critical data burst from the attaché's partisan reconnaissance network had just arrived. The intelligence packet confirmed the suspected flight direction, the low-altitude profile, and the specific geographic corridor the Mi-28 was most likely to pass through. The squad of 6 immediately split into 3 separate interception teams and spread out across 3 critical choke points. The first tactical team deployed 2 Shrike-10 drones to monitor the heavy vegetation running along the main Moscow-Kharkiv railway. The second team quickly established control over the elevated terrain of the White Hills area. The final reserve team set up an ambush position near the Seversky Donets River Valley. In this valley, the low ground and riverside tree lines provided the perfect natural terrain masking for a low-flying helicopter. The stakes were absolute. If the drone teams missed the interception window, the Mi-28 would successfully complete the low-altitude air defense network. The gunship would detect the launch routes of the drones, relay the coordinates to Russian artillery, and fully intercept future aerial strikes. To prevent this failure, the Ukrainian forces relied on ZVUK. This was a highly classified acoustic early warning network secretly deployed along the dense border regions weeks in advance. The system did not emit a single electronic pulse. Instead, it used a vast grid of long-range radio links to transmit tiny data packets up to 8 miles away. Each node consumed less power than a digital wristwatch. Powered by small solar panels, each acoustic sensor station could operate continuously for weeks, without human maintenance. Thousands of camouflaged microphones and artificial intelligence directional sensors were bolted onto tree trunks deep inside shelter belts. They were strapped to border wire obstacles. They were rendered completely invisible to ground patrols and aerial thermal cameras. These silent nodes did one thing. They listened for the deep, steady, heavy thumping signature created by helicopter rotors and turbine engines. The physics of the trap were brutal and precise. Sound travels through the air at a constant speed of 1,125 feet per second. When the massive Mi-28 entered the listening zone, multiple scattered sensors recorded the exact millisecond the acoustic wave struck their microphones. By calculating the microscopic time delay between different receiving stations, the artificial intelligence system triangulated the exact flight direction, the forward speed, and the geographical position of the target. But the system went further than simple geometry. Every aircraft in the world leaves behind a unique acoustic fingerprint. The twin climb-off TV3117 turbine engines of the Mi-28 rotate at a violent 15,000 revolutions per minute. This massive mechanical effort produces a fundamental sound frequency band between 250 and 325 Hz. This specific low-frequency rumble easily penetrates thick morning fog, dense tree canopies, and heavy shelter belts. These are the exact environments where optical cameras are blinded and low-altitude ground radar fails to maintain a steady track. The artificial intelligence brain of the ZVUK network immediately compared the captured sound wave against a preloaded military acoustic library. Within fractions of a second, the network stripped away the background noise of civilian trucks, diesel tractors, and heavy wind. It isolated the exact engine scream of the Mi-28. By combining signal data from multiple overlapping directions, the network locked the position of the helicopter with an error margin of less than 150 feet within an 8-mile radius. The first remote sensor suddenly picked up a steady, repeating low-frequency pulse. This was the distinctive main rotor blade beat striking the air at exactly 20.1 Hz. Seconds later, 2 adjacent sensor stations confirmed the exact same signal. The target was acoustically locked. A multi-million-dollar machine was now blindly flying into a mathematical net. The control team waiting in ambush along the Moscow-Kharkiv railway immediately launched their first 2 Shrike-10 reconnaissance drones straight from the tree line. But calculating an interception point for a machine moving this fast requires a terrifying level of precision. Before we go deeper, make sure to like, share, and subscribe to the channel for more clear analysis on the weapons, battles, and geopolitical shocks shaping the war of today. The atmosphere itself became an active participant in this ambush. Thick morning fog layered heavily across the border region. The temperature difference between the cold ground and the warming morning sky created a strict thermal inversion. This environmental anomaly physically bent the sound waves downwards, bouncing the acoustic energy between the clouds and the earth. This literal atmospheric tunnel massively extended the detection range of the ZVUK sensor network. Instead of catching the heavy rotor noise at a single mile, the hidden microphones heard the distinct mechanical beat from 3 full miles away. The Russian flight crew maintained absolute radio silence. The heavy gunship followed the main Moscow to Kharkiv railway at a constant speed of 110 miles per hour, holding a dangerously low altitude of 120 feet. The pilots used the iron train tracks, the dark shelter belts, and the scattered ground structures for visual navigation. They deliberately kept their active radar systems completely powered off. Emitting radar waves would instantly alert Ukrainian electronic intelligence, so the pilots relied purely on their eyes to remain practically invisible. The interception geometry was brutally unforgiving. The operators could not simply launch their weapons and chase the machine. A drone moving at 80 miles per hour can never catch a helicopter moving at 110 miles per hour from behind. The human operators had to predict the exact geographical coordinate where the Mi-28 would appear in the future. They had to fly their aircraft ahead of the helicopter flight path and wait in the sky. Wind speed, signal delay, battery degradation, and approach angles all had to align with absolute mathematical perfection. The Ukrainian squad had exactly 9 minutes left to solve an interception equation no drone unit had ever successfully faced. The weapon itself was a paradox of modern war. The Shrike-10 featured a lightweight carbon fiber frame, commercial electric motors, and standard optical cameras sourced entirely from civilian supply lines in China. But strapped tightly beneath the fragile plastic chassis was a heavy Russian fragmentation warhead, recovered directly from a destroyed tank on the battlefield. An explosive charge originally designed by the Russian military to kill Ukrainian infantry was now being flown back up into the sky to destroy a Russian attack helicopter. Suddenly, a critical hardware failure threatened the entire operation. Heavy morning moisture had severely corroded the metal detonation contact point on the primary explosive payload. The firing signal flickered constantly. If launched in this unstable state, the drone would physically strike the glass cockpit, but the heavy warhead would fail to detonate. The operator immediately dropped to the wet soil, ripped off the protective plastic casing, and desperately cleaned the metal connections. He restored the stable firing circuit just as the launch window began to violently close. But just as the interception geometry was perfectly set, the target suddenly changed the rules of the game. Instead of continuing straight down the railway line, the heavy gunship banked hard west. The pilots abandoned their straight flight path and entered a completely different geographical corridor towards the White Hills area. The calculated ambush point was instantly rendered useless. The entire tactical plan shattered in a single second, forcing the drone operators into a desperate gamble. From a strategic satellite perspective, the battlefield shifted from a clean, linear interception into a chaotic scramble. Invisible acoustic waves continued to ripple across the topographical map, tracking a target that was now actively dodging the predicted kill zones. At the exact same time, massive invisible electronic sweeps began to saturate the entire valley. At the White Hills ambush point, the secondary control team scrambled into their new firing position. The operator slammed a fresh battery pack into his flight controller, but the system refused to recognize the power source. The heavy moisture from the rapid movement through the wet forest had critically damaged the internal connector pins. The control screen flashed bright white for a fraction of a second, and then died completely. The primary weapon system was dead. Every single passing second carried the Mi-28 another 150 feet closer to absolute safety. With absolutely no time for slow hardware repairs, the team ripped a backup Shrike 10 from their transport bags. The entire digital synchronization process had to be restarted from zero. The operator rapidly forced the controller connection, the receiver pairing, and the secure video channel configuration. The first video feed was flooded with heavy static interference. The second communication channel received zero signal. On the third violent attempt, the camera feed finally stabilized, revealing a trembling image of wet tree trunks through the thick fog. The drone was armed and ready, but the lost time meant the Mi-28 had traveled another full mile away from the designated kill box. Farther south, the Seversky Donitz team received the updated vector data. To catch the drifting gunship, the drones now had to turn west and cut diagonally across the new flight path. The operator slammed the throttle stick forward. The drone skimmed over the wet grass and accelerated straight into the thick gray fog. The optical camera became completely useless, leaving the operator to rely purely on an electronic compass and an artificial horizon to maintain the correct heading. But the strict laws of physics heavily favored the heavy helicopter. The freezing morning air began to violently drain the chemical energy from the drone battery packs. The power level plummeted rapidly to 70%. The drone possessed just enough energy to reach the intercept zone, but absolutely zero energy for a second attack run. If the first pass failed, the weapon would fall dead into the trees. It was a single-shot weapon. While the Ukrainian operators fought against failing hardware and freezing temperatures, a massive shadow war erupted across the electromagnetic spectrum. A heavy Russian Krasuka 4 electronic warfare system began to brutally sweep the operational area. The truck-mounted jammers pumped megawatts of invisible energy into the sky, hunting specifically for the radio frequencies controlling the incoming drones. If the radio link is severed, the drone falls. If the drone falls, the helicopter survives. The Shrike 10 responded by aggressively jumping across 50 different communication channels per second. Every single time the Russian electronic warfare crew locked onto a suspicious data stream, the drone had already shifted its frequency to a new band. The trees and wet cliffs reflected the radio waves, creating massive signal confusion for the Russian jammers. But the interference level eventually surged to a critical point. The optical video feed on the controller screen broke into heavy digital blocks and then vanished entirely. Without a human operator to physically guide it, the drone immediately switched into a pre-programmed autonomous mode. It relied entirely on internal inertial sensors and loaded visual maps to recognize the tree lines and the ground terrain below. Surviving the invisible electronic onslaught was an engineering miracle. But the drone now had to physically confront the brute force of a heavily armed flying machine in a violently confined space. With their electronic shield bypassed and their heavy armor exposed to cheap autonomous drones, how do you think Russian aviation forces will adapt their flight doctrines to survive this new era of aerial warfare? Drop your strategic assessment in the comments below. At exactly 10:21 hours, the heavy fog was suddenly torn open. The Mi-28 burst into the exact predicted intercept point. The highly skilled Russian pilots had flawlessly executed their radar evasion tactics. They flew low. They hugged the ground tightly. They utilized the narrow valley below White Hills to mask their massive radar signature. But this supreme tactical discipline became their ultimate death sentence. The physical terrain completely locked the aircraft into a geographic coffin. A dense forest pressed tightly against the left flank. A vertical rock face formed an impenetrable wall on the right flank. The helicopter could not rapidly climb without instantly triggering Ukrainian surface-to-air missiles. It could not violently bank left without shattering its main rotor blades against the solid environment. The apex predator was perfectly trapped inside a narrow atmospheric hallway. The lead drone hovered precisely 16 feet above the dark tree canopy. The electric motors spun at the absolute minimum speed required to maintain altitude. The battery indicator ruthlessly bled from 50% down to 40%. The freezing air mercilessly drained the chemical lithium cells. The operator held the drone in total stealth, silently waiting for the heavy target to cross the invisible kill line. Two backup drone groups established secondary and tertiary trap layers deeper inside the valley. The heavy mechanical roar echoed violently through the narrow corridor. The 20.1 Hz acoustic wave smashed against the rock face, bounced through the wet tree trunks, and flooded the acoustic sensors. The distance rapidly collapsed. 800 yards, 500 yards. A sudden break in the dense tree canopy allowed a single beam of morning sunlight to strike the thick glass cockpit of the Mi-28. That brief optical reflection provided the exact final targeting vector. The Ukrainian operator pushed the throttle completely forward. All four electric motors instantly surged to maximum RPM. The Shrike 10 exploded out of the dark tree line and climbed vertically toward the exposed belly of the heavy gunship. But the attack immediately hit a massive physical barrier. The violent downdraft from the spinning main rotor blade struck the solid cliff wall and rebounded directly back into the valley. This massive wall of turbulent air slammed heavily into the lightweight drone. The camera feed shook violently. The drone was physically thrown completely off its intended trajectory. If the drone strikes the thick titanium underbelly, the heavy armor absorbs the blast. If the drone misses the fuselage, the helicopter accelerates away forever. The operator violently pulled the control stick left. He fought the chaotic atmospheric turbulence. He forced the drone into a sharp banking maneuver around the main fuselage. He aimed the explosive payload directly at the single most vulnerable mechanical component on any rotary wing aircraft, the exposed tail rotor. The tail rotor alone counters the massive torque generated by the main engine. If the tail rotor shatters, the entire fuselage immediately spins out of control. The distance collapsed to 5 yards. At exactly 10:26 hours, the Shrike 10 physically slammed into the fragile tail section of the Mi-28. The live video feed instantly dissolved into total static. The digital screen went entirely dark, but the heavy column of black smoke rising from the Russian border carried a harsh, new reality that would permanently shatter modern military doctrine. The heavy attack helicopter immediately pitched violently downward. The massive machine lost all directional stability and crashed directly into the cold ground near Vazovoy in the Belgorod region. The complete video record of the tactical attack was released to global intelligence networks by Commander Robert Matyar Bravdi of the 427th Independent Unmanned Systems Regiment. The dedicated aerial hunter had officially become the hunted. The financial and strategic asymmetry of this single impact is completely staggering. An advanced military aviation platform valued at $18 million was utterly destroyed by a commercial plastic frame worth a few $100s. The multi-million-dollar asset possessed heavy armor, advanced electronic countermeasures, and raw turbine power. The cheap plastic drone possessed a salvaged explosive charge, a basic optical camera, and an absolute mathematical advantage. If an $18 million machine cannot survive an encounter with a plastic toy, the entire economic foundation of modern airborne warfare instantly collapses. This catastrophic loss was not the result of a single lucky physical strike. It was the ultimate ruthless culmination of a perfectly executed kill chain. The invisible ZVUK network gathered the raw acoustic intelligence. The artificial intelligence algorithms solved the complex geographical equations. The human operators forced the flying machine into a fatal physical trap. Expensive military technology does not guarantee ultimate survival. Total tactical patience, precise mathematical calculation, and perfect environmental exploitation form the new apex weapon of the modern battlefield. Does this specific interception mark the definitive end of the traditional attack helicopter era? If this analysis helped you understand the battle more clearly, hit like, share this video, and subscribe to channel for more updates on war, weapons, and global politics.